Hi everyone. So in this video, I will be showing you my recent project which is based on autoencoders. So if you don't know what autoencoders are, so this is the basic architecture of autoencoder. It consists of two parts, encoder part and decoder part. Well, the main task for encoder is to compress the high dimensional data into a lower dimensional space, which is called latent space. And the decoder, what decoder does is it reconstructs the image from the latent dimension. Okay, so this is the basic architecture for the autoencoder. Okay, so now let me show you my project. So this is the GUI. Basically you can import any image. Let's say we will import this image and then you will give the epoch number. Let's say train it for 100 epoch. Now this autoencoder is designed so that it can be trained on your local machine. So now we train. Now see, you can see the real-time changes in the latent space and the reconstructed image. So basically this GUI is showing you how an autoencoder is learning, how encoder is able to encode the information in the latent space and how the decoder is able to reconstruct that image. If we increase the epoch, let's say 300, then you can see now why is there 4 images in the latent space. So what it does is it converts the 256 by 256 by 3 pixel image, which is the width and height are 256 pixels and the channels are 3 red, green and blue colored image. So it converts this image into basically 32 by 32 by 4. So these are the 4 channels in the latent space which you can see. But this image is converted into 32 by 32 pixel. So all the information in this image, or not all, but most of the information in this image are lost. Yeah, so now it is trained. So you can see the architecture of the model here, 256 by 256 by 32. Then basically it's a bottleneck structure. So after 256, 128 by 128, then this max polling convolution, and then 64 by 64, then 32 by 32 by 4. So this the latent space. This is the latent space. 32 by 32 by 4. This is the latent space. And then again it upscale the image 64 by 64. So the downscaling and upscaling should be symmetrical in autoencoder. Okay, so you can see this is symmetrical 64 by 64 and then from 64 to 128 and then again to 256 by 3. So just one more thing, if you are familiar with the concept of autoencoder and you have your own architecture of autoencoders and you want to visualize the latent space and reconstructed image, then you can download my code from GitHub. I will paste the link in the description box and then just open this file autoencoder.py and in this file you will find the architecture of the model here. So just paste your architecture here and just remember to add this line in your latent space. So in my case this is the latent dimension or latent layer in my model. So I pasted this line, I named this layer as latent space. Yeah, so if you have your own model, then you can download my code and then you can paste your model here and just write this line after your latent space. So I hope you like this project, and if you have any kind of suggestion, you can write it in the comment section. And yeah, thank you for watching.